Hello everybody. This video is intended for my dynamic section MEC 3850 at Wentworth. And I've already talked about the absolute motion analysis. Remember, we talked about there are three different ways that we could do velocity analysis for what type of motion. For general plane motion, right? General plane motion is what type of motion? A motion which is part translation, part rotation. So one method is absolute motion, which is limited in a way. One method is relative motion, which I'm going to talk about, and there would be an example also as a video that you will see later on in an email sent to you. And another method is the shortcut, which will also have a bunch of videos on that, called the instantaneous center of zero velocity, which is actually the easiest way to solve problems related to velocity. Okay, so here I have this situation where at a given instant, right, if a body is in general plane motion, so imagine if this link AB, bar AB, which could be like a connecting rod, is going through combination of translation and rotation. So point A has a given velocity of VA with some magnitude and direction, as you could see. And then it says if the velocity of point A is given and angular velocity of the bar is given at this instant, which you can see this bar is rotating clockwise, right? Then we should be able to find velocity of point B, right? So let me show you how that's done. Okay, if we start with the relative motion equation, which is, say, if you want to find velocity of B relative to A, by definition of relative velocity, that's VB minus VA. If you rearrange the equation and solve for velocity of B, then you would have VA plus VB slash A. Now, in this equation, this is actually the translation part of the motion, and this is the rotation part of the motion. So this is translation with respect to A, and this is rotation about A. When you add these two, what you get is absolute velocity of point B, and that's what we want. And this could be done with respect to any 2 points on the body. If you know velocity of 1 point on the body and you know omega of the body, then you should be able to find velocity of any other point, like velocity of B. So let me just explain what this VB slash A mean really. VB slash A basically means find velocity of B, not the absolute velocity, velocity of B as if A is fixed. Okay? And I'm going to show you in the next page what I mean by that. So find velocity of B as if A is fixed. What does that mean? That means that if we have our bar like this, if we make A fixed, right, we know the body is rotating like that, what would be velocity of this point? If, let's say, this bar has a length of L or R, you guys know that in pure rotation velocity of a point, if the body is rotating about this axis through A, right, would be what? First of all, this is VB slash A, and this VB slash A would be R omega. R is the length of the bar, which I called it R, and omega is omega of the body at that instant. Or if you want to do it vectorially, which I don't advise you to do it that way because it's not worth it for the type of problem we do, it would be omega cross R, as shown earlier in another video. Okay, so basically once you find this VB slash A, then you can go ahead and say, okay, look, what is velocity of B? Velocity of B was velocity of A plus VB slash A, right? So velocity of A, look, velocity of A is like that. So this is velocity of A. I should have had actually in this guy in a different color so we can color code it. So this is the rotation part of the motion, VB slash A, velocity of B as if A was what? Fixed. Okay, so now if I show you this guy, so this is this, right? This one is this. And then the sum would be what? Head to tail method would be V sub B. So here we go. This should be velocity of B. So you guys remember in the previous page we had velocity of A like that, and we had omega of the body like that. So I just determined that velocity of B should be something like this, as shown here. So this, of course, if it doesn't make sense, you have to see a problem. So in the next video, I have a problem just like what you see here in this explanation. And then we have a bunch of other examples related to movement of a bar or rolling motion and so on. Okay, as always, thanks for watching and listening.